Chameleons are famous for their remarkable ability to camouflage by blending into their environment and hiding from predators. The skin cells of chameleons contain pigments known as chromatophores and are directly controlled by the brain, enabling quick response to natural or social changes. However, the capacity for color change varies. Take for example the family Chameleonidae with over 150 species of chameleons. In some, color change is limited to shifts in brightness, for example shades of brown, while others show extensive chromatic color change by showing many color combinations of blue, green, orange, and the list goes on. My chosen journal, titled Selection for Social Signaling, drives the evolution of chameleon color change, refutes that camouflage, also known as crypsis, is the driving force of evolution in chameleons and examines two primary processes for the evolution of this adaptive strategy. Number 1, natural selection for the ability to camouflage against various backgrounds. Number 2, selection for conspicuous social signals to conspecifics. A phylogenetic comparative approach was used to test for selection for crypsis, if selection for crypsis or the selection for social signals, or a combination of both, drives the evolution of color change. A spectrometer was used to detect coloration and color change in field-based behavioral trials using 21 lineages of southern African dwarf chameleons, their habitats ranging from grassland to rainforest. Figure 1 shows a plot depicting mean color change measured in all three body regions, top flank, mid flank, and bottom flank, in high contrast to its vegetation background. Based on the crypsis hypothesis, chameleons should match its colors according to a variant of background colorations in response to predators. However, this does not prove right in Figure 1, displaying background matching with or without a predator, although the ability to alter its brightness is directly correlated in the presence of a predator. In the case of social signaling, chameleons communicate bright color patterns to signal dominance or submission in male contest and courtship, as this picture over here shows chameleon in aggression by color signaling duels. If you think about it, this is very much like humans in how we express body language, displaying different emotions through various facial expressions. The greatest capacity for conspicuous chromatic color change happened during these interactions, rather than color matching to its surroundings, as it would if the driving force of its evolution had been the ability to blend in.